Sabi Africa. No Africa. No Africa's pioneering role in science, engineering, and technology.
Sabi African Network, illuminating Africa's narrative as pioneers in science, engineering, and technology.
You've probably heard the myth that advanced metallurgy only arrived in Africa with colonialism. That's not just wrong, it erases one of the most sophisticated engineering traditions on the planet. Long before industrial steelworks, blacksmiths across Africa were running complex bloomery furnaces, refining iron ores and crafting tools with principles any material scientist would recognize. This wasn't guesswork. It was engineered. It was tested and optimized over centuries. Let me show you how. Start with the furnace. A bloomery is a charcoal-fired reactor that reduces iron oxide without melting the iron. Sounds simple. It isn't. You need the right geometry and the right clay, the right ore, and tight control over airflow. Smiths adjusted tuyères, the air inlets, like precision valves, tuning draft and temperature to produce a solid, workable bloom. If the slag got too viscous, the reaction stalled. If the air was too strong, the iron burned. Hitting that sweet spot, that's thermodynamics, fluid dynamics, and fuel chemistry, learned hands-on. Across West and East Africa, archaeologists have unearthed furnaces and vast slag heaps. In Central and Southern Africa, workshops and production sites date back more than 2,000 years. The evidence isn't just age, it's sophistication. Tall natural draft stacks and clustered tuyères engineered for steady reactions. Controlled tapping kept chemistry on track and heat flowing. Once the bloom left the furnace, the forge took over. Smiths cycled heat and hammering, driving out slag and aligning the metal's microstructure. They carburized edges, adding carbon for hardness, then quenched and tempered to balance toughness and durability. It's the same logic behind modern heat treatments: control time and temperature, and carbon to shape performance. Only here, it was encoded in craft, not textbooks. And the tools? Purpose-built, hose tuned to specific soils, axes balanced for dense hardwoods, blades with hard edges and tough spines, composite handles designed to be repaired, not discarded. Each iteration was feedback-driven engineering. Test, tweak, repeat. These workshops were more than factories. Blacksmiths were engineers and entrepreneurs, ritual specialists, and teachers. Their forges were hubs of training and innovation, powering agriculture and architecture, trade and early political systems, local ore, local clay, renewable charcoal, tools made for long service, slag repurposed for roads and construction, low waste, high resilience. Zoom in on the diversity. Hausa Smiths refining edge geometry for farm tools. Buhaya furnace masters perfected natural draft so strong the furnaces breathed on their own. Southern African iron centers linked to early states coordinated production at scale. Different environments, different solutions, same scientific mindset. The bigger point, African ironworking wasn't borrowed and it wasn't primitive. It evolved locally, adapted to local materials, and followed the fundamentals of materials science: control variables, measure results, optimize for purpose. If you care about appropriate, sustainable tech, this legacy matters. It's a roadmap for systems that are efficient, repairable, and rooted in place. Not just a past to celebrate, but a toolkit we can use. The science in these forges is as real as any lab. If this shifted how you see African technology, like, comment, and subscribe. See you in the next one.